Hello and welcome to my presentation of NRGISE, which is a Python simulation framework for energy storage systems, which we are currently developing at the Fraunhofer Institute for Solar Energy Systems. So we are creating NRGISE with three major goals in mind. One is to really find the optimal sizing of the energy storage, meaning, for instance, the capacity and the power of the storage. Also, to find the optimal control strategy for the energy storage, because as you might know, you can use energy storage for 1,000 different things, from trading to maximizing the self-consumption of your PV system to enabling fast charging of electric vehicles. And lastly, we also want to find the perfect energy system configuration, meaning how many batteries do we use, or how many fast chargers do we use in our energy system configuration. And we want to do this by including a detailed cost model. So we talk to industry partners a lot about cost modeling to have verification from industries there, and also to include detailed storage aging models. Because if you use battery a lot, it ages, meaning it dies faster, so you need to replace it, which is quite expensive. And now I want to quickly dive into how is it roughly built. So basically we do have two main components. The one is the energy system, which is a model of the energy system itself, which can be built in a modular fashion using the framework. So you can throw in multiple or no battery. You can throw in a PV system, a grid, diesel generator, or a charge point for electric vehicles. And then on the other hand, you do have a controller, which can be something like a simple rule-based controller or something more fancy like model predictive control or reinforcement learning. And those two communicate with each other through state and action, making it basically a Markov decision process. So we created a simulation which enables this. Yeah. So we can use this basically to look at one energy system, but as I said in the beginning, we are interested in the, let's say, best one, so we need to simulate multiple ones. And what we did here is basically to use grid search. So you can create a search space or a grid. For instance, here it's shown it's two-dimensional, so you define different storage sizes or different control strategies, and then every combination of those is simulated. We do this in a parallel fashion, and the simulation is quite fast, so it's feasible for us. Also, we are not only in the best option, but also in all options to see the differences of, what do control strategies have an impact. Okay. So, just one quick example. Here, it's shown we showed the impact which different control strategies have on the profitability of an energy storage in a, let's say, small industry context. And what you can see is if you basically combine self-consumption optimization and peak shaving with your energy storage, you can basically increase the profitability a lot. So, and you get the right size for the storage as well. I would skip this, and yeah, if you are interested or if you have any questions, just visit me at the poster or contact me. Thank you.